Okay, this is my model of the larynx. I will start out by pointing to all of the cartilages in the hyoid bone. So we have the hyoid bone in black. We have the thyroid cartilage, the cricoid cartilage, the arytenoid cartilage, the cuneiform cartilage. I know they are underneath the aryepiglottic folds, but I went ahead and put them in there. The cuneiform, or the corniculate cartilages, those are the cuneiform cartilages, and the epiglottis and the aryepiglottic folds. Next, I will do the intrinsic muscles. So we have the thyroarytenoid muscles, which are along the vocal folds. Then we have the posterior cricoarytenoid muscles, which are right here. The lateral cricoarytenoid muscles, which are right here on the sides. Then we have the transverse arytenoid muscles, which go laterally right here. Then we have the oblique arytenoid muscles, which crisscross right here. And then we have the cricothyroid muscle, which is back here, and I just have it shown on one side because I needed to make room. I wanted to be able to show the membrane on this side, so it is normally on both sides, but I just have it shown here on one side. So next is the thyrohyoid membrane, which is right here between the hyoid bone and the thyroid. Then the cricothyroid membrane, which is right here, and it goes all the way around with the muscle. Then we have the first tracheal ring right here, and the cricotracheal membrane is right above it between the cricoid and the first tracheal ring. The cricothyroid joints are right here between the cricoid and the thyroid, right here and right here. The cricoarytenoid joints are right in here between the cricoid and the arytenoid. And then the aryepiglottic folds are here in white. And then the superior laryngeal nerve is up here, and the recurrent laryngeal nerve is down here. So first I will explain respiration as it relates to voice production. So as we inhale, the diaphragm contracts and drops, the rib cage expands and allows for air to rush into the lungs. The vocal folds adduct after the air comes into the lungs due to negative air pressure above the vocal folds. Then as we exhale, the diaphragm relaxes and returns to its resting state. And this, we use the muscles of the rib cage along the wall, and they act in conjunction with those of the abdominal wall to generate expiratory forces that are needed for speech production. Then the subglottic air pressure increases and air rushes out of the lungs. Vocal folds are then abducted, so they are blown apart, and the pressure in the lungs returns to that of the atmospheric pressure. Next, I'll talk about the necessary and sufficient conditions for phonation. First, you need adduction of the vocal folds, so the vocal folds need to be closed. The phonatory threshold initiates the vocal fold vibration. Then you have medial compression, and this aids in the tone and the tension of the vocal folds. And then longitudinal tension is the last one. Next, I will describe the function of each intrinsic muscle. So first we'll start with the thyroarytenoid muscle, which are along the vocal folds, and these are responsible for phonation. They stiffen the vocal folds and contribute to pitch. Next are the posterior cricoarytenoid muscles, and these pull back and down on the muscle processes to abduct or open up the arytenoids and therefore the vocal folds. The lateral cricoarytenoid muscle helps to adduct, so bring together the arytenoids, so it pulls the vocal processes together to the midline. transverse arytenoid muscle, which is one that goes across, and then the oblique arytenoid muscle, the X, the one that crosses. Both of those pull the posterior edge of the arytenoids together during adduction. And then the cricothyroid muscle, which again is on both sides, it decreases the space between the cricoid and the thyroid, and it lengthens, it helps lengthen the vocal fold to increase the pitch. Next, I will describe how the cartilages move in relation to each other and effect that each have on the vocal folds. So first we have the arytenoid cartilages. They are the connection point for the vocal folds. They allow for adduction and abduction. They rock, glide, and slide atop the cricoid cartilage, and they consist of the muscle process and the vocal process. Next is the thyroid cartilage, and this is the primary support for the vocal folds, and it's also the protection for the vocal folds. Then we have the cricoid cartilage in green, and this supports the arytenoids and the thyroid. So the arytenoids sit on it and it supports the thyroid. And the arytenoids sit atop the cricoarytenoid facets. Then we have the epiglottis in purple. This is closes as you swallow for protection of the airway. It is attached to the anterior surface of the thyroid, and it is an attachment point for the airy epiglottic folds. And then we have the cuneiform cartilages, which there is no known function for them, and the corniculate cartilages, and there is no known function for those either. Next, I will describe the nerve supply to the intrinsic muscles. So first we have the recurrent laryngeal nerve, which is down here, and this supplies, this is the nerve supply to all the intrinsic muscles except the cricothyroid muscle. And the cricothyroid muscle is supplied by the superior laryngeal nerve, right there. So next I will talk about the myoelastic aerodynamic theory of phonation. And so the air pressure opens the glottis during each vibration. The vocal folds come together again during each vibration due to their elasticity, and then the sudden drop in pressure between the folds as the air streams through the open glottis. And then the mucosal wave is the movement of the mucous membrane of the vocal folds during phonation, and it's called, it's named thusly because the vibrations move it quickly. It makes it look like a wave because the inferior part is coming together and then the superior part is happening quickly. And this is the model of my larynx.